Hello and welcome to this talk about import maps that might be the next evolution step for micro frontends. I want to start with a picture. Have you ever seen something like this? A good old mechanical typewriter. This brings up childhood memories. I remember my mom had one. And she showed it to me when I was about 4 years old. At least I was in preschool, in kindergarten, and I really loved it. Pressing all those buttons and stamping some letters on the sheet of paper, a physical carriage return, and this ribbon with two colors, black and red. I was really amazed by it. And I also think I even destroyed it a bit because I played around too much with it. However, funnily, if we look a bit more closely to such an old mechanical typewriter, we see something that should be quite familiar nowadays, namely a good old QWERTY layout. The thing is, QWERTY has been around since about 150 years and it will not go away. There are several studies telling us that there would be other arrangements of the keys, more ergonomic arrangements. However, we stick with QWERTY. We stick with QWERTY for a reason. We needed to learn to write on a QWERTY layout. This was quite an effort, and it would be too much effort to move the whole industry away from QWERTY to something else. That means somehow we are locked in with QWERTY. And we have the same situation in the area of software development quite often. Something like a vendor lock-in, where we are locked in into one vendor or one given technology stack. And finally, micro frontends help you to deal with this vendor lock-in. Because if you go with micro frontends, you subdivide a huge frontend into tinier parts, so-called micro frontends, and they can be written with their own technology stack. We can also migrate them little by little, step by step, to new stacks, or if there are new, more modern stacks, we could just use it for new verticals, for new micro frontends, and keep the other ones as is. So it's a really nice approach to deal with this lock-in effect. However, when we talk about micro frontends, we also need to talk about runtime integration. Because everything is compiled and deployed separately, that means only at runtime we can grab those moving parts and integrate them in a bigger whole, into something you might call a shell. Here we see the shell on the left side and one of the micro frontends loaded into the shell at runtime at the right side. However, runtime integration is really difficult. There are several workarounds people are using for years and decades. Workarounds like iframes and workarounds like loading web components on demand. However, those approaches have come with quite an effort in the past. We needed to implement a lot of infrastructure code by ourselves to make those workarounds work. And that's why I'm really happy that since about 2.5 years we have Webpack Module Federation. For me it was really a huge game changer because Module Federation suddenly allows us to load something from another application into the middle of ours. Could be a component, could be a routing configuration with several components, could just be a function. We can seamlessly load something that was separately compiled and deployed into the middle of our application. However, there is a little tiny drawback when it comes to Webpack Module Federation, namely Webpack. Well, nothing against Webpack. Webpack is really a successful build tool and it is heavily used out there. All the communities use it. They have several million downloads a week. This is quite a number, isn't it? Nevertheless, Interestingly, to deal with a vendor login, to prevent a vendor login, now we use a technology that has a vendor login, a vendor login into Webpack. And in the long run, this is for sure a drawback. In the short run, everything is fine with Webpack. However, currently we see that there are several alternatives for Webpack coming up. Alternatives that really challenge Webpack because they are faster, they are written with native technologies, and so they are faster, and they're also easier to use because they come with typical things out of the box you need to configure when going with Webpack. And that's why they are currently really successful. And I think this shows we need to find a way to loosely couple module federation to Webpack. And this is the question I want to answer today. How to bring the Mandel model of module federation, the Mandel model that is quite a smart one, to other platforms in an easy way. How to re-implement it in a tooling agnostic way so that it works with all the bundlers available today and available in the future. And for this, I want to come up with a browser native approach. The good thing is everything that is browser native will be supported in the long run. Already nowadays, still things that have been implemented with JavaScript in the 90s work. Perhaps you don't want to use them anymore, but they still work. Everything is backwards compatible. This is how the web works and how the web evolves. That's why re-implementing module federation with such an approach would really help to use module federation for the next decades. For this, I want to go with ECMAScript modules and quite a new approach that is called import maps. To tell you about this approach, I have prepared several things for you. First of all, I want to give you a primer into module federation. No worries, I won't talk a lot about it because there are a lot of other talks about this topic, but I want to make sure everyone is in the boat, and so I have prepared 2 or 3 slides about this topic. Then I will proceed with import maps. We will look into them and find out what they are about, and then it's time for a marriage. Then we will marry both technologies together, and this is where I will show you how to re-implement something like module federations on top of import maps and other browser native technologies. Before we start, let me introduce myself. I am Manfred, I am a trainer and consultant for Angular, and I'm focusing on Angular in the enterprise. Angular for enterprise scale applications. I'm doing a lot of workshops and consultancy in this role. I'm also quite connected to the Angular community. I live in Austria, I do a lot of stuff in Germany, and I'm always happy if I can work together with people around the globe. Okay, let's get started with module federation, a little tiny primer into module federation. If we look to module federation, then we see that this technology subdivides our applications into 2 roles. The first role is the host. In our case, it's the Micro Frontend shell. The second role is the remote. In our case, it's the Micro Frontend itself. Both roles are configured with the Webpack configuration. For instance, when it comes to the shell, we map this or that logical URL to this or that Micro Frontend. That means we make this or that URL pointing over here or there. And over there, we can expose files. Each Micro Frontend can expose files that can be loaded into the shell. Normally, the shell is not interested into your real file names and into your physical structure, into the structure of your projects, all the folders and so on, and that's why it's quite usual to assign an alias here. and then something beautiful happens, then everything you need is an import statement that uses the map names to grab over and to load something from over there at runtime. Something we did not even know at compile down. This is quite nice because in this case your framework of choice does not even recognize that something special is going on here. We are just doing business as usual. We use our framework in the usual way as it was intended to be used, and everything else works magically underneath the covers. No dirty workarounds anymore. Little tiny technical detail, we need some metadata about the micro frontends. This metadata is emitted by a remote entry JS file. You can switch out the name, but in my cases the name is remote entry.js, and it contains a little tiny amount of JavaScript informing the shell about this micro frontend so that the shell knows how to interact with it. This remote entry needs to be loaded somehow into the shell, with a script tag for instance, or perhaps with a script loader in a dynamic fashion. A really cool feature of Webpack module federation is you can share libraries. Let's say we are using Angular and you are using Angular over there. In this case, it would not make sense to load Angular several times. It does not make sense to load Angular 10 times just because of having 10 micro frontends using Angular. With module federation, it's possible to just load it once and share it at runtime. And this is as easy as just putting the package to share into the configuration. Of course, when sharing dependencies, we might end up with version mismatches, like DLL hell in the 90s. If you used Windows back then, you will very likely remember DLL hell. And that's why module federation comes with some baked-in strategies for compensating for version mismatches. One strategy is by default, it selects the highest compatible version. The highest compatible version, which is most likely the highest minor version. So let's say one micro frontend goes with version 10 and we have this caret in our package.json, and another micro frontend goes with 10.1. Now the highest compatible version is 10.1 and it will be loaded as the only version. Also instead of 10.0 it will be used instead of it, because with this caret we told the system, in this case the package.json, that we are also fine with a higher compatible one with a higher minor version. This is the default behavior. However, you might have a conflict. There might be a situation where there is not a thing like a highest compatible version. Just imagine we have 11 here and 10.1 there, and no special characters like greater or equal. In this case, module federation loads both of them. This is for sure a hit on your bundle size. However, besides this, if bundle size is not your utmost concern, it might be okayish. It might be okayish that this part of the application is using another version as that part. Of course, if we talk about different versions of your main framework, we need some tricks like hiding details of those framework versions or hiding them behind web components, for instance. But if we just talk about a stateless library, this should be fine if bundle size is not your highest architectural goal. You can even configure your dependencies as singletons. You know, if you go with singleton true, you have the Highlander principle. There can only be one. That means only one version of this library will be loaded. Let's assume we have 11 here and 10.1 there. In this case, only one version will be loaded, which is the highest known version, which would be 11. 11, regardless if it is backwards compatible to 10.1 or not. It does not have to be backwards compatible in terms of semantic versioning. If you are lucky, it might work, but no guarantees. That's why when using this approach, you get a warning. You get a warning in the browser console, in the JavaScript console, telling you, well, this might go wrong. Are you sure you know what you are up to? If you don't want to have a warning but a slap into your face, then you set strict version to true. Then you get an error message instead of a warning. And I really like this, because this makes me fail fast. And failing fast is awesome, because it makes me easily find out that something is wrong, that there is something I need to correct before we go into production. So I would say, whenever possible, use singleton together with strict version. Okay, so much about module federation. As we have seen, module federation allows us to easily load something from over there. Our framework does not even recognize that something special is going on. Plus, we can deal with version mismatches. Now, let's have a look into import maps. And as we will see at first glance, import maps have been envisioned for quite a different use case. However, there are similar mechanisms in there, and so we can use it to re-implement module federation. But one step after the other one, let's have a look into import maps. What you see here is traditional ECMAScript code. I'm using date functions to find out about the weekday of a given date. I want to see if this holiday, at least it's a holiday in very Catholic countries, if this holiday is on a weekend or if I can benefit from it because it's during the week. And yeah, for this I'm going with date functions. That means I need to import date functions, which is not a big deal. The big deal is all of this directly runs in your browser. We have script type module. This directly runs in your browser. While we have ECMAScript modules for quite a time now, using them directly in the browser was not really possible, because resolving those names in the browser was not possible. Instead, we needed to bundle this code in a way that the browser could find out about where to load date functions from. The bundler could have inlined date functions here, or it could have emitted some bundler specific code into your bundles that is pointing to the other bundle containing date functions. So in the past we needed a bundler, now we can do this directly in the browser because of import maps. Because import maps are a simple data structure mapping those names to this or that bundles or to this or that ECMAScript modules. This is what I'm doing here. Here I'm setting up an import map, a very simple one, and I'm saying, hey, every time someone is importing something from date functions, please grab it from over there. Could be a bundle, could just be the entry point of your library over there in the form of a JavaScript file. And if we go one step further, if we map names that point to other applications, then suddenly it's quite easy to load something from over there at runtime. A module from over there containing, let's say, a component, a routing configuration with several components, or perhaps just a function. We can even deal with version mismatches. We could say, well, when this guy here, this app, is importing date functions, let's resolve this name this way. Let's use this version of date functions. And if that guy here is importing date functions, that application, then let's resolve date function with that version of date functions. And finally, even though import maps have been intended for a different use case, This is more or less what module federation is doing when it comes to compensating for different versions. Loading both of them, one version for here, one version for there. But we can even go one step further. We can dynamically create import maps. Because an import map is just a script tag with type import map and this data structure in it. So we can tinker it by hand. And this means we can manipulate it. We can set up an import map that is resolving version mismatches in the sense of just load the highest minor version. Ignore other lower minor versions, just go with the highest minor version. So it is quite straightforward to also mimic this behavior of module federation. Can we use import maps nowadays? Well, the good message is most of the desktop browsers support it. We don't speak about IE anymore, that's also a good message. And when it comes to mobile devices, there is some room for improvement. However, we can polyfill it in a production-ready, high-performant way. This guy here, Guy Bradford, who is a well-known and very valuable community member, implemented a nice polyfill. It is using WebAssembly underneath the covers to be capable of parsing the bundles quite quickly and to tweaking the bundles so that they work with import maps. It really works nicely, and funnily, this shim gives us even more features than native import maps. So we are on the safe side here. Now let's think about re-implementing module federation with import maps. Well, if you wanted to do something like this, you needed to deal with three areas. You needed to deal with metadata. Somehow you need to provide metadata about this or that micro frontend, because we need to know which versions of our dependencies are needed here and there. Also, you need to deal with bundling. You need to bundle everything that needs to be loaded from over there into our application. You need to bundle it separately, and you need to set up your import maps in a dynamic way. When it comes to metadata, you need to provide this metadata at compile time. When compiling your application, you need to look into your package.json, find out about version numbers and write down this metadata. And you need to load it at runtime. When it comes to bundling, you need to bundle all the remotes separately. You know, remotes are the files you want to load from over there into your shell. You also need to bundle shared packages separately, because we want to decide if we are going to load Lodash from here or from there, who has the highest compatible version. And we need to respect, in my case, the Angular compiler, because I'm an Angular person. If you go with another framework, you need to support your compiler. Meanwhile, it's quite usual that a compiler needs to run over your source code to make it seamlessly work with your framework. It's currently the case for Vue, Svelte, and a lot of other frameworks. When it comes to import map, we need to generate the import map dynamically, and we need to deal with scopes. We need to set up scopes dealing for version mismatches. The thing is, if you want to do a proof of concept for all of this, you need 1 day or 2 for a proof of concept. If you want to implement this in a nice reusable way, if you want to implement this as a more or less drop-in replacement for module federation, you need about 2 or 3 weeks. I know this because I've done it. I've done it for you. It is available here, SoftArc Native Federation. It implements all those ideas and currently works quite nicely with several frameworks. We have examples for Vue, Svelte, we have examples for Angular, and so on. It does not work that nicely, frankly. It does not work that nicely with React. The reason is a simple one. React is currently not using ECMAScript modules. We try to do our best to migrate the source code to modules, but there is no 100% safe way to do this. So in some cases there might be issues. But if you use a framework that is currently already providing ECMAScript modules, and as it turns out, most other frameworks do nowadays, then this works really nicely. This all is implemented as a stack of 2 layers. The low-level layer is native federation, soft arc native federation. I also call it the core library. And we have some examples with Vanilla.js, also React, where we convert the React dependencies to ECMAScript modules and ESBuild. And then on top you can add some integrations for more heavyweight frameworks like Angular. For instance, for Angular we have Angular Architects Native Federation. You know, when going with Angular, your build task is shielded from you. It's hidden behind the covers, so you need a little tiny plugin to tweak your build task to use this technology. And a good friend of mine, Giorgio from Italia, has also implemented a plugin for Vite. We tried it out with Svelte and also with Vue and also with Analog.js, which is a community project that runs Angular on top of Vite. And of course, you can provide your own integration. But I think nowadays with a Vite integration and an Angular integration, you should be fine. This is what's used by most frameworks nowadays, at least when they start moving away from Webpack. Okay, let me show you a demonstration for all of this. So what we have here is a shell application. Here we have a micro frontend. It's within the red dashed lines. And when I'm clicking here, the micro frontend is seamlessly integrated into the shell. It's directly loaded into the shell, even though we are talking about 2 different applications. This here runs on localhost 5000, this here runs on localhost 3001. And no, this is not a prerequisite. You don't have to go with different ports, not at all. But by using different ports in this demonstration, I really prove that we are talking about 2 separately compiled applications. Let's have a look to the browser console when loading the micro frontend. Let's press F12. Let's go to the network tab. Where is it? Oh, here it is. It's already open. Let's click here. And you see not much is loaded. Just the micro frontend itself is loaded, which is in this case just a component with 1.5K. It's really not much. We don't need to load Angular and all the other libraries again because they are shared. And to make this happen, to share libraries, I just needed to configure native federation in the same way as I would have configured module federation. It's really almost the same. Let's have a look to the source code of all of this. Here we have the federation config of our micro frontend. And as you see here, we have the same properties as you would have put into your module federation config. We need to assign a unique name to our micro frontend. We can define to expose JavaScript modules. In this case, it's an Angular module. It could also be a routing configuration, a standalone component, or just a function. Everything that can be expressed with ECMAScript can be exported here. Everything and more. And we need to define what to share. Normally, for this we needed to go with an exhaustive list, like telling us I want to share Angular core with this or that configuration and Angular common with this and that configuration. However, I found out by myself that maintaining exhaustive lists is quite exhaustive. And that's why instead of this, I'm going with another approach here. I'm calling it an opt-out approach. I'm sharing everything with share all. This looks into my package JSON and shares everything I have in there with those settings. And if I want to not share something, in order to optimize my build, I can just put it in here into a skip list. Like, let's say, Angular common testing is nothing I want to share because I don't even need it at runtime. There is also a parameter here in share all for the skip list, but I think this syntax is a bit more readable and more maintainable. So it's really what we are used to go with when we know module federation. We have the same situation here for the shell. However, my shell configuration is a bit smaller. I'm just defining what I want to share. Because, sharing is always an opt-in. We need to share on both sides. Just to give you a little tiny example, if I want you to share your dessert with me, I need to opt in. No worries about this. But also you need to opt in. Otherwise, it's not sharing. Otherwise, it's theft. And this is not considered to be polite nowadays. And very likely it was not even considered to be polite in the past. So you have to make sure on both sides that you want to share. Normally, you would define your endpoints here, your paths, your remotes. You would say, well, there is a remote MFE1 over there, and so on and so forth. However, I don't want to do this. This would work, but in my case, I have moved this to a separate file because, like the Webpack configuration, also the federation config is only used at compile time. However, the paths pointing to other micro frontends need to be switched out at runtime, and that's why we have a separate file for it. I'm calling it the manifest. The federation manifest telling us, well, this micro frontend is found over there. Over there you have the remote Android JSON. In my case, it's a JSON, not a JAS file containing the metadata. When we bootstrap our shell, we need to initialize the application with the manifest. This is reading all the metadata, and then we can bootstrap the application by importing a file that bootstraps your framework in the usual way. Please ignore these squiggles, this is just an issue of my IDE. And I also think this is a quite common pattern in the world of module federation. Read all the metadata so that we know which dependency is loaded from where, and then import your remaining application where the dependencies are resolved according to the decisions we've done before. Loading Angular from here, loading Lodash from there, for instance. And then all you need is just lazy loading. All you need is just a lazy route. In this case, I'm going with the Angular router pointing to this import here, to this remote. And from this remote, which is a TypeScript file, I'm taking this export that is called flights module. An ECMAScript module, a TypeScript file, can have several exports and one default export. And here I'm telling the router with which export to go. So it's really as simple as that. A traditional import, it looks like lazy loading for your framework. However, underneath the covers, import maps make sure that MFE1 is resolved and module is resolved. So where do those names come from? Well, if you remember, MFE1 comes from the manifest. We defined that MFE1 is the guy over there. And module is the alias exposed by the micro frontend. It's the short name we can use to get the exported flights module from over there. So just use a dynamic import and Bob's your uncle. If you don't want to go with a dynamic import, there is this helper function. You could also use it. However, it's a bit more verbose, but it's more dynamic. You can switch out those strings, which is not that simple with a dynamic import, because very often a dynamic import is directly compiled into your bundles. But with those dynamic strings, you're really good to go if you have a very highly dynamic situation where you don't know about your micro frontends upfront. If this is not the case, I would prefer import. And that's it. So as you have seen, this really works like module federation, but in a browser native way. So when can we use this? Is this already ready for prime time? And the answer is yeah, it's ready. You can use it. However, when we talk about the Angular integration, it's currently in beta. The reason is, for the Angular integration, we use the ESBuild builder for Angular. And the ESBuild builder for Angular is also still in development. There is a developer preview, and that's why this integration cannot be ready for prime time. However, once the Angular CLI team is ready with its ESBuild implementation, we will provide an integration to native federation on top of it. We already have prototypes, we already have a beta version, so it will not be that difficult. If you don't need the Angular integration, if you just need the with integration or a low-level integration where you directly go with ESBuild, it's ready for prime time. It's out there in version 1.0. For Angular, we need to wait a bit. That means if you have Angular, then I would currently start with Webpack module federation. If you have something else, you can already use native federation. And Angular people will have to work until Angular natively supports ESBuild, which will be in the next couple of months, I guess. We already have a developer preview, so it's only a matter of time. In general, native federation is my and your insurance for the mid and long term. It assures that everything you have built with module federation in the past, or everything you build nowadays, will also work in the mid and long term, because native federation has the same public API surface and it works in a browser native way. But you don't have any stress, you don't need to hurry and worry to migrate everything now to native federation. However, it makes us sleep better for sure. So if you liked all of this and if you are into Angular, I have more information about this all, mainly about production ready stuff that is already production ready in this free ebook, so feel free to download it here. Let me come to a conclusion. What did we see today? We have seen that the Mandel model of module federation really rocks, because it allows us to load something from over there in a seamless way, and it allows for compensating for version mismatches. We have also seen that import maps, even though they have been intended for a different use case, provide all the low-level building blocks we need to re-implement module federation. And we have seen we can really do this, and we already have a reference implementation for this idea. I call it native federation. It's our insurance for the mid and long term. It makes us sleep better. And last but not least, please remember this, namely, please beware the vendor login and mechanical typewriters. Okay, here you have my contact data. I have already uploaded my material to my blog. You find it there, and follow me on Twitter to stay in contact. Thanks for having me.